So, hello future doctors, welcome to Gyansrota. Today again we are going to start the PYQ sessions of 2012 chemistry. So, the first question is on your screen. Vapor pressure of chloroform and dichloromethane at 25 degrees Celsius are 200 mmHg and 41.5 mmHg respectively. Vapor pressure of the solution obtained by mixing 25.5 gram of chloroform and 40 gram of dichloromethane at the same temperature will be. They given the molecular mass of the chloroform, that is 109.5 U, and molecular mass is given as dichloromethane equal to 85 U. So, now we are moving to the solution part. So, this question is basically come from your solution chapter of your class 12 NCERT, okay, solution class 12 NCERT. So, which formula we are going to use here? So, we all know P total is equal to P note A x A plus P note B x B. So, x A and x B are nothing but these are mole fraction. Now, this one I am considering as A, that is chloroform as A, and this dichloromethane I am considering as B. Now, let us find out the x A and x B, that is the mole fraction of A and mole fraction of B. So, for mole fraction of A, we know what is the formula, that is number of moles of A divided by total moles, that is numbers of moles of A plus number of moles of B. Okay. So, if you see, we have to first find out the Na value and Nb value. Similarly, for xB, that is the mole fraction of B, is nothing but numbers of moles of B divided by number of moles of A plus number of moles of B. So, first let us find out the number of moles of A. How to find out? The given weight, how much weight of given chloroform? It will be around 25.5 gram. Okay. So, 25.5 gram. And what is the value of Na, what is the value of molecular weight of chloroform? That is 119.5. So, if you are solve this part, it will be end up with like 0.21. Okay. Now, mole fraction of B, if I am going to calculate, what is the weight given for B, that is for dichloromethane, it will be given as 40 gram. So, 40 gram divided by molecular weight, what is the molecular weight, that is 85. So, this is end up with 0.47. Okay. So, these two are the moles of A and moles of B. So, now see the value of mole fraction of A, it will be end up with like 0.21 divided by 0.21 plus 0.47, that is 0.21 divided by 0.68. Now, this one is end up with so it will be end up with around 0.31, I think, with 68 by 21 is equal to 0, that is if I am putting here 3, yes. So, it will also end up with 0.31. Okay. So, this value is end up with 0.31, that is the value of mole fraction of A. Now, mole fraction of B, again it will be similar as 0.47, that is moles of B divided by total moles. How much it will be? 0.68. How it will come? That is moles of A plus moles of B, it total is 0.68. Now, if you are solve this part, it will be end up with around 68 into 7. Okay. So, again it will be end up with 0.67. Okay. So, these are the values, this is the approximate values. So, please try it in your home by using calculators, or you can take your time to do the calculation. Okay. So, what you are end up here, your the mole fraction of B is 0.67 and mole fraction of A is 0.31. Now, the formula, which formula? This formula. Okay. So, what is the value of P naught A? That is be 200. What is the mole fraction of A? That is 0.31 plus P naught B. What is the P naught B? Like what is the pressure they are given here? It will be around 41.5. What is the mole fraction of B? It will be end up with 0.67. Now, do this calculation, 2 into 3, that is 0.3, sorry, 31 into 2, that is 62. 62 plus, if I am doing this part, so it will be end up around 27.80 something, okay, it will be coming in this form. So, if you do this one, sorry, this calculation is mistake here. So, 415 divided by 67. Yeah, it will be around 27.805, and if you do the remaining part, it will be end up with like it will be coming around 89 to 90 mm of Hg. Okay. But if you see this 89 to 90 mm of Hg, this value is not given in any options. In one option it will be giving 285, another one is 173, third one is 615 and fourth one is 347. So, here this question is a bonus question, okay, because answer is not matching with any one of your options. So, this question is a bonus question. Your first question itself a bonus question, and this answer is coming near to 89 to 90. So, now we are moving to the next question, that is question number 2. So, question number 2 is on your screen. The Gibbs energy for the decomposition of aluminum oxide at 500 degrees Celsius is as follows. So, they give you the reaction and they give you the value of delta G, that is 960 kilojoule per mole. They ask you the potential difference needed for the electrolytic reduction of aluminum oxide at 500 degrees Celsius at least. So, this question is come from your electrochemistry chapter of your class 12 NCERT. So, now we are moving to the solution part. So, if you see here, this question is come from your electrochemistry, and the formula we are going to here is delta G minus NF E naught cell, and we have to find out this E naught value. Okay. So, how to find out N here? So, this is the one of the critical part to find out the N for this reaction. So, but it will be very easy. So, see, for the oxidation state of aluminum here, it will be plus 3 and it will be 0 here. So, from plus 3 to 0, that change will give you the N value. So, N value here 2 by 3, how many is that? Stoichiometric 2 by 3, and your oxidation state for one aluminum is plus 3, and how many aluminum is there? 2 aluminum is there, so 2. So, 3 and 3 will be cancelled out and it will be end up your answer which 4, and 4 is the value of N. Now, the value should be substitute in this equation. So, if I am saying here delta G value is given as 960 kilojoule per mole. So, it will be first converted into joule, okay, 10 to the power 3 joule per mole. So, 960 into 10 to the power 3 joule per mole, N value is 4, F value is 96500 into E cell. Now, E cell equal to 960 into 10 cube divided by 4 into 96500. Now, if you solve this part, this equation or this mathematical expression, if you solve, your answer is come approximately 2.5 volt. So, if you see in your option number 4, where it is given as 2.5 volt is the correct answer of your question number 2. So, now we are moving to the next question, that is question number 3. So, question number 3 is on your screen. For successive member of the first series of transition metals are listed below, for which one of the standard potential value has a positive sign. So, this question is come from your electrochemistry part of your class 12 NCERT. So, now we are moving to the solution part. So, they ask about which of them are showing standard potential have a positive sign. Now, if you see, if you remember the electrochemical series which is below the hydrogens, their standard reduction potential value is positive, above hydrogens it will be as negative. So, below hydrogen only one option is there, that is your Cu, that is copper, which having the positive sign of your standard potential. So, option number 4 is the correct answer of your question number 3. So, now we are moving to the next question, that is question number 4. So, question number 4 is on your screen. Which of the following exhibit only +3 oxidation state? So, this question is come from your D and F block elements of your class 12 NCERT. So, now we are moving to the solution part. Now, this question is a direct question. Okay, so, which among of them are showing the +3 oxidation state, and your option is your fourth option, that is actinium. So, what is the configuration here? That is radon 7s 6d and 5f. 5f is 0 and 6d it will be 2 plus 1. Okay. So, this is the electronic configuration if actinium, right. So, your option number 4 is the correct answer of your question number 4. So, now we are moving to the next question, that is question number 5. So, question number 5 is on your screen. Molar conductivities at infinite dilution of NaCl, HCl and CH3COONa are 126.4, 425.9 and 91.0 Simon centimeter square per mole respectively. Delta M naught for CH3COOH will be. So, now we are moving to the solution part. So, this question is basically come from your solution chapter of your class 12 NCERT. Now, if you see here, they give you they ask you the molar conductivity of acetic acid. Okay. So, what is the formula for this? Delta M CH3 COOH. We have to find out for this. And what are the values they are given? They are given the values for delta M CH3 COONa, but we required COONH. Now, again if I am doing this one, delta M, delta naught M, and they given the value for HCl. Okay. Now, again CH3COOH, it will give you the CH3COOH, but we have to remove this Na plus and Cl part. Okay. So, how it will remove? If I am minus the value of delta M of your NaCl. See, we required for this one. So, how to find it out? We have to take this part, that is CH3COONa, this value is given, again adding the part of HCl. Now, if you see CH3COO and your H, it will be giving your CH3COOH, but we have to left out two parts, that is Na and Cl. Now how to remove this Na and Cl, that is NaCl, again we have to minus the value of NaCl, and at the end we are obtaining the molar conductivities of acetic acid, that is CH3COOH. Now just put the value of first one, it will be given as 126.4 plus for HCl it is given as 425.9, and for NaCl it will be given as, for first one they given the value of 91.0, okay. For HCl it will be given as 425.9 minus for NaCl how much they are given, 126.4. Now just do the calculation, 5 plus 1 that is 6, 9, 10, 11, 1 that is 516.9 minus 126.4. So if you see here, it will be 0 here, it will be 9 and it will be 390.5 Simon centimeter square per mole. So 390.5 is your correct answer. Now if you see among the option number 1 is the correct answer of your question number 5. So now we are moving to the next question, that is question number 6. So question number 6 is on your screen. In which of the following arrangement the given sequence is not strictly according to the property indicated against it? So now we are moving to the solution part. So they asked about which is not, okay. So first mark it, what they asked, not, which is not follow, okay. And if you see the first option, they are giving an increasing oxidizing power, yes, that is true, it is a true statement, okay. Now here also they are giving us increasing acidic strength, that is for halogen compounds, and this is also a true statement. Now if you see for third, water, sulfur, H2S, H2SE and H2TE, increasing pKa values. Now for this if you see old style say typo, what will happen down the group, the bond length with H2, bond length increases. When bond length will be increases, your bond energy decreases. When your bond energy decreases, your acidic strength will be increases. When your acidic strength will be increases, your pKa value should be decreases, okay. So what is the decreasing value of this and this, but they follow, they given you the opposite order, okay. So they ask about which is not strictly according to the property indicated against it. So your option number 3 is the correct answer of your question number 6, because if you see down the group bond length increases, when bond length increases, your bond energy will be decreases. When bond energy will be decreases, it will be very easy to leave these hydrogens. When H plus release will be easy, then that property is called as acidic strength. It means the acidic strength will be increases. When acidic strength will be increases, the pKa value decreases. But here in the options they are giving in a increasing order, which is the false statement, and this is the correct answer of your question number 6. So now we are moving to the next question, that is question number 7. So question number 7 is on your screen. They give in the reaction with aldehyde with hydrazine and they give you the product and they ask what sort of reaction is it. So now we are moving to the solution part. So this basically come from your GOC chapter of our general organic chemistry, and if you see this reaction, that is react with NH2 with your aldehydic, it will give this kinds of product, and this is nothing but this is your nucleophilic addition, then elimination will take place. How? Because this is a nucleophile, it will attack on this position like R C double bond O H, this one will be attack here, this one will be go on this side and your OH, and you will get this product. So, this is first a nucleophilic addition, then your elimination reaction take place. Now, if you see only one option they are given as nucleophilic addition and elimination reaction. So, your option number 1 is the correct answer of your question number 7. So, now we are moving to the next question, that is question number 8. So, question number 8 is on your screen. During change of O2 to O2 minus ion, the electron adds on which one of the following orbitals? So, this question is come from your chemical bonding chapter of your class 11 NCERT. So, now we are moving to the solution part. Now, if you see here, they ask about O2 to O2 minus ions. So, for oxygen it will be total electron count should be 8 into 2, that is 16. So, it will follow this order, right, because if it is greater than 14. So, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px equal to pi 2py, then your pi star 2px equal to pi star 2py, sigma star 2pz. Now, just try to fill the 2 plus 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and your 16. Okay. Now, for O2 minus, so what is the electron count here? Total electron count, that is 16 plus 1 and 17. Now, the added electrons, that is the extra electrons, is added on which orbital? They are going to add on your pi star orbital, right? In this orbital the electron is going to add it. Right, in this orbitals your electrons is going to add. So, in the question they ask you where electrons will go and add. So, if you see the pi star orbital, that is option number 2 is the correct answer of your question number 8. So, my dear students, today we try to solve more PYQ questions based on our chemistry knowledge and by using our small tricks. So, next class we are going to more details and try to solve more PYQ questions. So, till then keep studying and keep revising.